And this is just going to be total CMS. Okay, so now, this is a fairly large file. This isn't something that you do that often where you need to deal with 3 separate volumes like this, but in this case we're going to. So I'm going to do a union, and I want to union this one, and this one all together. But before I do that, let's do a mass property on each one. Okay. The red one. And then the gray one. Okay, so if you look, so 16.8, 15.4, and 13.1. And if I select all 3, 1, 2, 3, sort of do the volume of all 3 of them, and then add it together. So it'll be cumulative. So 45 is what the total is. So 16, 15, and 13 gives me a total of 45. But they share a great deal of their volume with each other, so the 45 isn't accurate. So in order to get an accurate volume, what I want to do is do a union between all 3 of them. This one, and this one. So it's combining them together, and wherever there's an overlap, it won't double count them anymore. So this is going to take a little while, so I'll bring up my timer here. Stop it and start this. I'll pause that. Okay, so that one took a while, so I missed it, probably 20 minutes altogether. Okay, so now we've got this shape. So if we rotate this, just take the rotation here. It takes a second to load it into memory. Hold on. Okay, so now it's in memory. You can see now it rotates quite quickly. And you can see now that they've really become one object. If I render it, you can really see the difference between them. And if I select them, you'll see it'll select the whole shape. So it's all one unit now. And the important part is the properties, so the volume properties of the shape. So mass property, select it. So the true volume is 19,000, not 45,000 that it was saying. So if I scroll up, you see that was the volume of all 3 of them. But the actual volume, if I were to fill it with water or whatever, is 19,200. Oh, sorry, volume down here. 19,229. Okay, so let's turn off my render here. And now I'm going to save as. Whoops, not save sa. Save as. I'll know what I was doing. Union CMS. And the last thing I want to do, and again, this is going to take a little bit of time to process, what I want to do is turn on my two drifts, and I want to do a subtraction. So subtract from this volume. I want to subtract this one and this one. Let's just get my timer back up here again. Actually, let's reset it. Start and hit enter. Okay, bring up my timer and put this on pause again. Oh, so that one was much quicker. So now if we minimize this, close this one here. Let's see what we get when we rotate this. So give it a second to load into memory. Okay, so if you look, you can see down here, it's cut the tunnel out. And you can see up top that it's cut the tunnels out of this area in here. And if I turn on the wireframe to realistic again, you can see that it's cut out the tunnels from the shape. So the result of that, if I grab this, now, so it's now 17,117 as opposed to 19,229. So it's removed roughly 2,000 cubic meters of material from that was represented by the drifts. So the drifts had already been previously extracted. So in order to get an accurate amount volume of what I extracted, then I had to remove those drifts. Escape. Okay. Now there's a couple other things we can do. I can cut this off here, because this will represent the drift, or I can cut this piece off here. But what I'm going to do now is save this. So save as. So union CMS drifts removed. And then I'm going to convert this back to a wireframe. So in AutoCAD, that's actually very straightforward. It's just convert to mesh. And then it'll convert it back to a mesh. So, because the problem is that solids are not supported by most mining software on the market. Deswick, Vulkan, Gemcom, Amine, ProMine. They don't like to deal with solids, even though that's the new modern format. They still stick with an archaic, older wireframe mesh format. So we tend to, in order to make it easier to make these, this is final information available, we convert it back to a mesh so they can bring it into their systems and enact their own processes to handle this file. So just finish saving this. It's a big file, so it takes a few seconds. There we go. All right, let me just turn off my realistic again. So I'm going to convert to mesh and click. And I'm going to create, that's 3D mesh. So this is a mesh format. I can then explode it down to 3D faces. So if it doesn't handle the mesh format, I can convert it to 3D faces and then have their processes go in and reunify them back into a defined shape. And that really is all there is to handling the unioning, the joining of multiple CMS scans. So here we are. This is now, you see it's a mesh. So I can explode it down to 3D faces at this point. If I look at it in 3D rotation, you see it's still a 3D object, I just can't now do volumetrics on it. It's still got the holes and everything in it. So when you bring it into another system, it's going to have to recalculate all the faces, see if there's intersections. So there shouldn't be any intersections. And that's where I'll stop my video.